Okay, y'all, so today you're going to have this lesson 4.3. So in your binder, we're at 4.3, so the next lesson. And we're talking about proportional and non-proportional relationships. So make sure you have your calculators out. You're going to use your calculators quite a bit today, so pause the video and get your calculators. Make sure you're open to 4.3 in your notes, okay? All right, so it says ratios or rates. So remember we talked about this. And the difference between a ratio and a rate is that a rate is always two different things. So it can be like gallons and miles. So two different things, right? And a ratio, it can be different or it can be the same. And this is when we did the conversions. So we converted feet to inches. And then we have everything that's inches, okay? So if ratios and rates of two different quantities are equal, so here's our first thing. If they're equal, then the quantities are considered proportional. If the ratios or rates of two quantities are not equal, then we say they are non-proportional. All right, so what does that look like? So here's an example. So we're going to look at this, Eric and Lucy, and we're going to see if their rates are proportional or non-proportional. So it says Eric and Lucy ran 20 minutes each on a treadmill at the gym. The table below shows the number of calories each burned after 5-minute intervals. So complete each table and determine the type of relationship. So calories and time. So my rate on this guy is going to be calorie per minute. So calorie per minute. So if I come over here to Eric, I want to look at this. Oh, there's a glare there. Hopefully you can see that now. So calorie per minute. So I would have 70 divided by 5, which is 14. So this first rate is 14 calories per minute. And then the next one is 140 divided by 10, which is again 14 calories per minute. 210 divided by 15, which is 14 calories per minute, and 280 divided by 20 is also 14 calories per minute. So all of these are the same. So the calories burned by Eric is proportional. So it's proportional to the time because every ratio is equal. So we call this a ratio, or there's a rate. I could say either one. The ratio or the rate is equal. It's all 14, 14, 14, 14. Okay? So now let's go over here and look at Lucy. So Lucy is 45 divided by 5. So we know that this is 9 calories per minute. And 90 divided by 10 is also 9 calories per minute. And 120 divided by 15. So let me put that one in the calculator. So 120 divided by 15 is 8. So this one's 8. And then I have 180 divided by 20, which is also 9. So because of this 8 right here, if we go down here and look at Lucy, calories burned by Lucy is non-proportional. And it says because the ratio of 120 to 15, remember it's calories to time, so the ratio is 120 to 15, is not equal to the others. All right? So what happened is, even though there's only one in here, that one makes it non-proportional. So that means that this is a non-proportional rate and this is proportional. So I'm going to do one more and then I'm going to let you practice a little bit. So it says determine whether the quantities in each table represent a proportional relationship. So I have the number of students per buses. Well, this is easy. So 24 divided by 1 is going to be 24. 45 divided by 2 is going to be 22.5. Now, if you don't know that, you put it in your calculator. So I have 45 divided by 2, which is 22.5. So 78 divided by 3 is 26.33. So this next value, 26.33, and 100 divided by 4 is 24. So these numbers are all different. So if they're all different, then no, this is not a proportional relationship. Okay, so that doesn't work. So one more here. Let me do this one. So if we have money per hour, if you remember, when we have a rate, money is always your numerator over the quantity. So money per hour. So 36 divided by 4 is 9, 72 divided by 8 is 9, 90 divided by 10 is 9, and 135 divided by 15, I can plug it in to make sure, it's also 9. So this is 9 all the way across. So yes, this is proportional. And if you look at the directions, it says, if yes, then give the constant rate. Well, this is the constant rate. So the constant rate is $9 per hour. All right, so now what we're going to do, I want you to go ahead and pause the video, and then there are 4 examples on the back, and I want you to go ahead and work the 4 examples. Remember, if it is proportional, you need to put the rate, and then turn the video back on and you can check your answers, okay? Okay, y'all, so here are the answers. Let me show you a couple things. So with this first one, I got the first number of 7, and I got this next number of 6.84. And at that point, I just stopped because I'm looking if it's proportional. Well, if it's proportional, they have to be the same. And if these aren't the same, then I know right away that it's not proportional, okay? With this one, I had to go all the way through, right? I had to go all the way through, and it was miles per gallon. So miles per gallon is my unit. Remember, you've got to have the unit. This part's important. All right, with this one, again, I went all the way across, and I ended up with 80 cents. So we talked about this last week. I'm going to go over it again. So you could have written this as 0.80. You could have written it the way I did, 0.80, or you could have written it this way, 80 cents. If you wrote this is wrong. Remember, this is 0.8 cents, right? So, and if you did this, this is wrong too, because is this 8 or 80 cents? You've got to have 2 digits for cents. So going back over here, any of these would have been correct. This bottom one is not correct. And then again here, I didn't even keep going because I see that that second time is not proportional. All right, so what we're going to do here is we're going to fill in the table. And when we fill in the table, all we're going to do is, it's almost like working backwards. So what happens is, I have Ben earns $8.50 per hour. So here's my unit rate, $8.50 per hour, bagging groceries at the grocery store, right? So if I write this as a little algebraic sentence over here, what I have is $8.50 per hour, okay? So now when I have this, what I know is that I have the hours worked here, and I have the money earned here. I don't know what this money is. That's what I need to find. So if this is hours, and this is money earned, then I have money equals money, and hours equals hours. Okay, so this is what the whole thing looks like. If I were to simplify this down a little bit, I have $8.50 equals money over hours. So if I'm going to solve this, so here's my, let me use a different color here. Here's my, my time is going to change, right? 4 hours, 8 hours, 10 hours, 14 hours. So if I look at this, this is super easy to solve, because if I'm solving for x, then I'm just going to multiply this side by 4, and I'm going to multiply this side by 4, and then this is going to give me my answer. So if I go over here and fill out my table, what I have in my table is $8.50 times 4, which is $34. So this is going to be 34. And then if I replace the 4 with the 8 down here, so I want to know dollars when you work 8 hours. So this one's going to be $8.50 times 8, which is 68. And then I have $8.50 times 10, which is 85. And I have $8.50 times 14, which is 119. So I know that this works because this tells me that it's a proportional relationship. So because this rate is not going to change, then I know all I'm doing is multiplying it through by this, right? if we look at this next one, it says a wide receiver can run 9 yards per second. So here's the important part, 9 yards per second. So this would be 9 yards per second. So here's going to be my yards, and here's going to be my time, my seconds. So if I plug this in, this number, again, my seconds is the number that goes in the denominator, right? So if I multiply both sides, I'm going to do the same thing that I did in this problem up here. I have 9 yards times the total amount of time. So in this case, it's going to be 1 second, and that's going to be the yards that he ran. So this one's going to be 9. So 9 times 3, 1 would be replaced with a 3. So 9 times 3 is 27. 9 times 6 would be 54. And 9 times 10 would be 90. Okay, I'm going to go ahead and pause the video, and I want you to work through the last 2 examples and then check your work. Okay, so here we are on the second part of this. So if you check your answers, so it says 30 cents per minute. So this is how I would set this up. Don't forget this is cost. So it's not 1.5, but it's 1.50, 3.60 because this is cents. It wouldn't be just 1.5. You've got to make this dollars and cents. And then down here, because it's 9, you can leave it at 9, or you can leave it as 9.00. Either one of those work right now. On the second one over here, when it's got homes per month, so I have 7 homes per month. So homes per month, so I'm multiplying my months times my homes. This is what this looks like. And then the second question says, determine how many homes they sell in 2 years. Well, this is months. So if this is months, then I have to convert this 2 years to 24 months. So it would be 7 times 24 equals 168 homes. So look that over for a minute, and then we're going to move on to something else. Okay, so if we go on, we're going to go on to 4.4 now. 4.4 is the next one. And up at the top of your paper, it should show that this is 4.4. So 4.4. So what's going to happen is what we did here is we found things that were proportional or non-proportional based on completing a table. All right? So now we're going to find proportionality algebraically. So I have these 2 ratios. So it says a proportion is an equation that states that 2 ratios are equal. So if you remember, we said we had something that was proportion or non-proportion. So proportion is basically equal. We just said that on the other page, all right? So determine whether a pair of ratios forms a proportion. You check their cross product. So if the cross product is equal, remember that's what this is, if the cross product is equal, then we know that it's proportional. So the cross product, this is where we do the whole butterfly thing, right? So I have these 2 equal to these 2. So what that looks like over here is A times D equals B times C. Now, if you remember, the order doesn't matter. So commutative property multiplication says we can move this around. So this is the same as DA equals CB. I don't have to show the multiplication dot when when I have 2 variables next to each other. I know that they're multiplied. Okay? So here's what I have. I have these 2 proportions. I want to see if they're equal. So if they're equal, I'm going to look at the cross product. So it's almost like I make an equal sign there, and I'm going to multiply these 2 together. So I'm going to say 6 times 20. And then I'm going to multiply these 2 together, 5 times 24. Okay, so if you put this in your calculator, 6 times 20 is 120. If we put this one in the calculator just to check it, I have 5 times 24, which is also 120. So 120 equals 120. This is true. So yes, these are proportional. All right, so I'm going to look at this one now. So I go this direction. So I would have 3 times 8. And I want to know if that's equal to these 2, which is 2 times 15. So 3 times 8 is 24, and 2 times 15 is 30. Well, 24 is not equal to 30. So we put this is not equal sign through here. So we say that 24 is not equal to 30. So this was false. So no, this is not proportional. All right? So if they're equal, then this is true. When it's true, yes, it's proportional. This was not true. They did not equal each other, so it's not proportional. Okay? All right, go ahead and pause the video and work through these examples, and then go ahead and turn it back on and check your work. Okay, some of these I should work, some of them I didn't. I'm assuming you're plugging this all into your calculator, so probably not a lot of work for you to show on this either. Okay? All right, go ahead and highlight any that you missed, and then I can go over those with you at help session. All right, so let's go down to solving proportions. So normally what happens is you're not asked if two proportions are proportional, two ratios are proportional. More than often, what happens is you're given one ratio or one proportion, and you're given part of another one, and we want to solve it, okay? But nothing changes between this process up here and this process up here. We are still, in solving proportions, we are still going to use the cross product. So we're still going to use our butterfly method as we solve this. So this time what happens is I have 12 times x, so 12x. And remember, the coefficient goes before the variable, all right? And then on the other side, I have this one, which is 3 times 16. So nothing's changed except for now I have a variable. So I am not checking to see if it's true or false. I have to solve for x. So this gives me 12x. 16 times 3 is 48. Next step is I divide both sides by 12. And so this gives me that x equals 4. So I know that this is true when x equals 4. All right? So I'm going to do something a little bit different on this next one. So on this next one, I look at this and I say, okay, if 7 is proportional to 21, so if 7 is to 21, 8 is to what? Okay, so if 7 is to 21. So if I look at this, hold on, get a different color here. If I look at this, to go from 7 to 21, I'm going to multiply by 3. So 7 times 3 is 21. So whatever I do to the top, I have to do to the bottom, just like this. So 8 times 3. So 8 times 3 is going to be k. So 8 times 3 is 24, so k equals 24. Now, let's do it with the cross product, and you'll see that we're going to get the same answer, right? So if I do this way, I end up with 7k. And if I do this way, I end up with 8 times 21. So I have 7k equals 168, right? So here's what we have. I have 8 times 21, which gives me 168, and then I divide that by 7, and I get 24. So when I divide both sides by 7, I get k equals 24, which is what I had up here. Okay, so let's go back to this one. So if I go from 12 to 3, I'm going to divide by 4. So 12 divided by 4 is 3. So up here, I have to take 16, and I have to divide by 4. So 16 divided by 4 is 4. And that's what we had down here, that the answer is 4. All right. Now, this is a great method if everything is divisible. So if 12 is divisible by 4 equals 3, or if 7 times 3 equals 21, then this method is going to work. Okay. Now, that doesn't work down here for number 11. So there's nothing I can do to 26 to make that equal 5. That doesn't work. Now, if this is 25, it would work, but it doesn't work going here. So the only way I can solve number 11 is with my cross products. So I have 5w equals 6 times 26. So when I plug that in my calculator, 6 times 26 is 156. So 5W equals 156. I divide both sides by 5, and I get W equals, and that's not going to be even, 31.2. So 31.2 is what W equals in this. Okay? So let's look at this one. 9 times what equals 63? Well, I can do this, and I can say 9 times 7 equals 63, right? But I'm going the opposite direction. So I have to go this direction to get 9. So 63 divided by 7 gives me 9. So if I divide 63 by 7, I get to 9. And I had to go backwards because I'm going backwards this time. So 14 divided by 7 equals 2. So A equals 2. Now, if you don't see that, that's okay. You don't have to do it that way. You can do it the other way because it's always going to work. This way is going to be 63A, 63 times A, and on this side I have 9 times 14. So 63A equals 14 times 9 is 126. And I divide this by 63, and I divide this by 63. So if I have 126 divided by 63, I got 2. So A equals 2, which is what I had up above. Okay? All right, so what I want you to do is go ahead and pause the video and work all of the examples on the back, 13 through 18. So I want you to work on those and then stop at the challenge question. All right, we'll stop at the challenge question. Okay, so this is great. This is a really good problem to show you. So what I started when I was working on this key is I'm like, okay, 16 and 30, that's easy. So 30 divided by 5 gives me 6. But then I go up here and I would have to do 19 divided by 5, but I can't do 19 divided by 5 because that's not going to give me a whole number. Now technically it does, because here's what I have. 19 divided by 5 is 3.8. Uh-oh, sorry, I got a glare here. There we go, 3.8. And if I do this crisscross method, I still get 3.8. So either way, this would have worked, right? So if I do cross product, I get 3.8. If I do this and I know I'm going to divide by 5, if I take 19 divided by 5, like I did here in my calculator, I still get 3.8. So again, even though it's not equal, you still end up with the same answer, okay? All right, so here are the answers. You can go through and check your work. I didn't work everything out. If you've got questions, you can log on to Schoology, and all my class notes are in the folder for today. So you can go and look at all of my work. I've got everything worked out on Schoology already, okay? All right, so let's look at these challenge problems. So even though it says challenge, you have totally done this. This is not anything that's new for you. So we're going to do the same thing. So this says hint distribution, but we're going to set it up the same way. So if I do this, I have 3, but now I'm multiplying by this entire numerator. So everything has to be in parentheses. It's 3 times the whole thing, which is x minus 2. And on the other side, I have 2 times 12. All right? So at this point, I can distribute or I can solve and then divide. So I'm going to distribute first. So I have 3x, and then I go to the second one, minus 6 equals 24. So if I add 6 to both sides, this gives me 3x equals 30, or x equals 10. Okay, so let me do one more. If I do this one, I have 5 times the entire numerator. So the entire numerator is a plus 7. And then on the other side, it goes this direction, so 2 times 10. So this time I'm going to divide instead of distribute. So this side becomes a plus 7. Let me leave the 5. I'll keep another step in here. And that equals 20. So now I'm going to divide the whole thing by 5 and the whole thing by 5 here. So this cancels. Those 5s cancel. And so I have a plus 7 equals 4. 20 divided by 5 equals 4. So now I subtract 7 from both sides, and I have a equals negative 3. If you choose to distribute, you would have gotten the same thing, A equals -3. All right, so go ahead and pause it and work these last two. All right, y'all, there's the last two. So go ahead and pause this if you need to, if you want to check your work. And then to do some practice, there's a riddle. So the riddle that you have in your binder, it says, why is it a shame that parallel lines have so much in common? So as usual, as we've done these before, so one partner, you get the letter side. The other partner, you get the number side. The numbers and the letters are going to line up here with matching answers. And you fill that in the riddle down below to get your answer. Okay? This is your practice. When you finish with that, then you can get started on your homework.